What is going on, guys? Welcome to another video in my tutorial series, and today we are going to be talking about the half adder. Alright, and what a half adder is basically a device in our computers that takes in two inputs, two binary single bit inputs, we'll call this A, B, and it's going to give us a single bit sum and a single bit carry. Okay? And a couple of things to know is, like I've mentioned before, it only takes in single bit numbers. Okay, so what are those numbers? 0 or 1. Alright, easy as that. Now the next thing to note that it does not take in any carries, okay, from perhaps a previous sum. So that is one of the disadvantages of a half adder. It does not take in perhaps another carry here. Alright, so all it does is it takes the sum of two inputs and gives us a sum and a carry. Alright, now enough of me talking. I think you'll really get it once I draw a truth table for this thing right here. So, like I've mentioned before, a half adder has two inputs, A and B, and we're going to list them right here. And what are the outputs it has? Well, it has a sum and a carry as output. Alright, so that's what we're going to list out here. The next thing we're going to do is list out all possible values of A and B. So we have 0, 0, 0, 1, 1, 0, 1, 1. Now, when we have 0 plus 0, because remember, that is the functionality of this half adder, right? When we have 0, we have 0 plus 0, we want the value of 1 with the carry of nothing. There should be no carry. Alright, if you're unsure how I got this from, try to find some videos on binary addition, and I'm sure you understand this, okay? And we have 0 plus 1 should also give us a value, oops, I'm sorry, right here, that should be at 0. So when we have 0 plus 1, that should give us a value of 1 with a carry of 0, and when we have 1 plus 0, that should give us a carry of 0 and a value of 1. And lastly, when we have 1 plus 1, that should give us a value of sum of 0 but a carry of 1. Now, if you're not sure about this, like I said before, you should find some videos up on binary addition, but just for the sake of things, I'm just going to explain this real quickly, just as a quick reminder, refresher. When we have the value 1 plus 1, remember, this gives and these are in binary. Okay, so when we have the value 1 plus 1, this is going to give us a sum of 0 and a carry of 1, and this is going to be pulled along and comes down eventually. Okay, so that's that, and this is essentially our truth table for a half adder. Now why don't we go ahead and draw the functions for these items right here. So let's take a look. We have S, our output here, and let's take a look at the first one. Well, we have an output of 0, right? So anything and 0 is going to give us a value of 0. But just for the sake of things, I'm just going to go ahead and just write it all out. So we have 0 for the first input here. For the first row, 0 times and not A and not B. This is going to give us a value of 0. Now for the second row, we have not A and B. Is going to give, and since this is 1, well, I'm just going to omit 1. On to the next row, we have A, not B, and same thing, I'm going to omit 1. And down to the last one right here, let's go ahead and do that. We have 0, A, and B, and this is going to just be 0. Alright, let's see, I'm just going to, now that you've seen how I've gotten that, I'm just going to go ahead and simplify that. We have A, not B, plus B, not A. And believe it or not, this is the same thing. This is the exact same thing as this. I'm not going to go ahead and show how this is done, but if you are interested, trust me, do a quick Google search, and I'm sure you'll find out why. In fact, you can even mess around with this with your values, and you'll see why this is an equivalent of the XOR function right here. Now let's move on to the carry. For our carry output, as I mentioned before, and as I've shown you guys before, anything, as long as our output is 0, the whole little equation is going to turn into 0. So the only thing we have to look at here is the last output here, where we have 1 as our carry. So let's take a look. A and B is going to be it for C. Alright, so these are going to be our 2 outputs. Now let's go on ahead and draw the actual implementation of the logic diagram. Now, the first thing that I noticed, well, first thing, why don't we put down the inputs? So we have A as our first input and B as our second input. Now we have 2 lines here, and let's do S first for sum. Alright, we know it's connected by an XOR gate, a XOR gate. So why don't we go ahead and draw that because of this, so we know it's an XOR gate. Let's see here what I want to do. Let's see, let's put S here, and it's connected to A and B. So we're gonna wire up A, wire up B. Alright, easy enough. Now let's move on to our carry, and our carry is going to be comprised of an AND gate, because remember, multiplication is the equivalent for an AND gate. So let's go ahead and do that. Our carry, and I'm going to connect our A and our B, and there we go. That is the logic diagram for an AND gate. Now, I hope you guys enjoyed this video. If you did, please don't forget to hit that like button, comment, and subscribe. It really helps me out, and I'll see you guys in the next video. Bye-bye.